Okay, if you are referring to the video, this is the MCQ answers that we are having for the 2017 paper, O-level, right? So now we are switching to the paper discussion. So the first question that you are asking me to discuss is the third one. Yeah. So it says the hexadecimal equivalent, a bigger number, is equals to hexadecimal equivalent that they are asking of this binary number. So the binary number is bigger in this point, right? So let me right, let me make this bigger. So you are going to divide this number into 4-bit groups. Which goes like this. Right, so each and every group contains the place value 1, 2, 4, and 8. Yeah, sorry with my pen drive, people, like my interactive pen is not. Hold on, people, I will switch to my smartboard so it will be easier for to discuss. Give me a second. Right, perfect. Okay, so this is the people. I think you can hear me clearly, right? Okay, great. So we are going to divide this into the group which has 4 bits, right? So likewise, so each and everything contains the place values like 1, 2, 4, and 8, right? So that's how this is going to go. So adding this one and this one means 8 plus 2. That means this gives us a 10. Right here it's 1, 2, 4, and 8. Again, this here we got ones. That means 2 plus 1. This gives us 3. Right in here 1, 2, 4, and 8. It is asking us to add 4 plus 2, which is 6 over here. And here we got 1, 2, 4, and 8. We have 8 plus 4 plus 1. That means 13. And here we got only 1. So that gives us 1. So the final answer is going to be this one is indicated as 1. This 13 is indicated as D. And this 6 indicate as 6. 3 indicate as 3. And this 10 indicates as A. So 1D63A, which means the second one. Right? Is that clear? People who have got it wrong? Okay, great. Right. So moving forward. Right. So the fourth one says, consider the following statements. 2b is equivalent to 53.8. 2b16 is equivalent to 53.8. Again, we have some calculations to do. So let's see, 2b hexadecimal equal to 53.8. So let's see. 2b can be easily converted into the octal by converting first into the binary. So if this is a hexadecimal value, so then b can be, b means it's 11. 11 is going to write within 4 bit groups, right? How you are going to write it? So the 4 bit groups, they have the place value of 1, 2, 4, and 8. Right? So b means it's 11. So 11 can be created how? 8 plus 2 plus 1. This has a 0. Right? And 2, it's going to written in a 4 bit value as well. So then 2 is going to be 1, 2, 4, 8 is going to be the place values. So 2 can be treated as 1 over here and 0 on all other places. Right? So the binary equivalent is going to be 0, 0, 1, 0, 1, 0, 1, 1. Right? So now what we are going to do is we are going to divide this into 3 bit groups so we can find, oh, that's big. Hold on. Right, so we are going to divide this into 3 bit groups. So each and everything contain the value of 1, 2, and 4, not 1, 2, and 3. 1, 2, and 4. So this goes the same way, 1, 2, and 4. And we really don't need to convert this because it's 2 zeros, right? So how this is going to be? Here it's 2 plus 1, which means 3. Here it is 4 plus 1, which means 53, right? So this is in octal, right? So that means this is equals to 53.8. So the statement A is correct. Statement B says 4310 is equivalent to this particular one, 101011. So 101011 means it's this, the same value that we have took, right? So if we are going to convert this into a decimal, 101011, right? So what are the place values are going to be? it's 1, 2, 4, 8, 16, 32. All right, so we are going to add 32 plus 8 plus 1 plus this one plus 2 plus 1, right? So 38 plus 8 is 40, 40 plus 2 is 42, 42 plus 1 is 43. Yes, so it gives us 43 in decimal, right? So 4310 is equivalent to the 101011. And again, it's asked the same binary value 101011 is equals to 538. Of course, it's the one we take over here, right? So the C is also correct. So everything is correct. The answer is going to be fourth one, A, B, C, all. All right, people, is that clear? Okay, right. Then you have asked me to do the seventh one. Let me see how the seventh one is. Okay, so seventh one is about logic gates. Okay, seventh one is talking about which of the following truth table is equivalent to the logic circuit given below. Yes. So first of all, we have to take the output of the logic gate or the circuit that is given to us. So when A is provided from this corner, this is going to give you an A bar, right? So when you provide A bar over here, since this is providing B, B is going to be here. This is a NOR gate, so you are going to receive A bar plus B's total bar, right? So because that is the thing that NOR gate is performing, right? They add up and then invert A bar plus B's total bar. So now we are going to see what's going to be the output of A bar plus B's total bar, right? So to do that, we can have column A and column B. So we have combination 0, 0, 0, 1, 1, 0, and 1, 1, right? So then I'm going to create a bar because I need that a bar in my equation. So it's going to be 1, 1, 0, 0, right? And then I'm going to prepare a bar plus B. So I can take this and these columns. I'm just adding those things. So 0, 0 plus 1 gives you a 1. 1 plus 1 gives you a 1. 0 plus 0 gives you a 0. 1 plus 0 gives you a 1. Then I'm going to form A plus B's total bar. That means the opposite of this thing. 0, 0, 1, 0. I can take it from this particular column. So 0, 0, 1, 0 provides from the second answer. So the answer is going to be the second. Right. Okay. I guess it is clear to you. So I'm moving to the next one. If you got any questions during the things that I'm doing, so please ask, right? Always ask. Okay, moving to the number 8. So number 8 stays here. So number 8. It asks which of the following logic circuit has a truth table equivalent to the truth table of the logic circuit shown on the right hand side. Yes. When you are given a question like this, the way that you are going to argue is like taking the truth table for each and every circuit, right? So you have to draw the truth table for each and every circuit, not like you are going to draw it separately. You can just use one big table to do this, right? I'll show you how to do that. So when first of all, we have to take the output of the main circuit, right? Which means this. Hold on. What's going on with my pen? Okay. First of all, you have to get the answer for this. All right. So how we are going to have the output? This is going to give you A bar. This is going to give you B bar. And this gives you A bar plus B bar. All right. So now I'm going to create the truth table for that expression. All right. So what I can do is I can have AB columns like 0, 0, 0, 1, 1, 0, not enough space. Right, so I have A and B over here. So 0, 0, 0, 1, 1, 0, and 1, 1. Right. So then I'm going to take this output. So first A bar, then that means 1, 1, 0, 0. Then the B bar 1, 0, 1, 0. Then I'm going to have A bar plus B bar. All right. So A bar plus B bar means 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. Right? So now I need to figure out which circuit is going to tally with this. So I'll start from the first one. So this is A, this is B, and this is a NAND gate. So that gives us the output A dot B's total bar. Right? So then I can create A plus B total bar in the very same line. So what I have to do is like add these two and invert. 0 plus 0 is 0. Inverted, you get 1. 0 plus 1 is 1. Inverted, you get a 0. Right? And 1 plus 0 is 1. Inverted, you get a 0. One plus 0 is 1, inverted, you get a 0. 1 plus 1 is 1, inverted, you get a 0. Right? So, oh, I'm sorry. I did 1 plus B total bar. What we are having is 1 dot B total bar. My bad. Let me correct it. Here, what we are going to take is not 1 plus B, it's 1 dot B. Right, so that means A dot B's total bar. So like 0 into 0 is 0, inverted, it's 1. 0 into 1, it is 0, inverted, you get 1. 1 into 0 is 0, inverted, you get 1. 1 into 1 is 1, inverted, you get a 0. So we don't need to move further. This output is identical to this output, right? That means this is the correct answer. Right? So if you just not had the answer at the first one, so you have to solve the second one. So it's like A dot B's total bar, and for the that from this, and for this, it receives B over here. So it is A dot B's total bar plus B. Right? So then we have to draw that from here and see how it happens. Right? But fortunately, we got first one as the correct one. Okay, so that's how the 8th goes, and then the 10th one. Yeah, in 10th one, they are asking, consider the memory. I'm sorry. Hold on. Consider the following statement. Registry memory is a computer has a small capacity than that of a hard disk. Yeah. So like when it comes to the computer memory, there is a certain hierarchy for us to learn, right? I think you can remember the hierarchy. So let me remind it to you. So how the memory hierarchy works, registers stays at the top, then the cache memory, then the RAM, then comes the secondary storage. Right, so registers are at the top, then cache, then RAM, and the secondary storage in a rough order, right? So like if you think about from top to bottom of this hierarchy, this is size, it is smaller, right? The size is getting bigger, the physical size downwards the hierarchy. And access speed, registers has the greatest access speed, cache has less than that, RAM has less than that, secondary memory is lesser than that, right? And access time goes the other way around. If you have a biggest, or like if it is the fastest one or the highest access speed, the time is smaller. Access time is small. Cache takes more time than that. RAM takes more time than that. And the secondary storage takes the highest access time, right? So the statement A says register memory in a computer has a smaller capacity than that of a hard disk. Yes, of course, hard disk is a secondary memory and register comes at the top. So register is small because it stays inside the CPU, and hard disk is big in size, right? Registers comes in kilobytes. Hard disk storage, they usually go with gigabytes and terabytes. The data access speed of a register memory is slower than the speed of a hard disk. No, that is wrong. Data access speed, the highest data access speed has for the registers. It is the fastest memory that we can find. And secondary storage comparatively is the slowest one. And per bit cost to store data in a regular register memory is higher than the per bit cost to store data in a hard disk. Of course, because if we want to buy a register, we have to buy a CPU. So CPU costs like how many? Like now it is nearly 100,000. And when it comes to the hard disk, you can find it for 15 to 20,000, right? So cost per bit is higher in registers. So A and C are the correct answer. Right. Then the 11th. So the 11th says, consider the following statements. Log in into a computer using a stolen user ID and password of another person. Yes. So what they are asking is like, what creates the ethical issues, right? Not the legal one, the ethical ones. Logging into a computer using a stolen user ID and password of another person. Yeah, that's going to be an ethical problem. It's correct. Downloading and installing a free and open source software without paying for license. Now, free and open source software does not have any license, so you don't need to pay. So it's not going to be an ethical problem, right? We cannot be. The manager of an online shop selling a list of email addresses of his customers to a marketing company without the consent of the customer. Definitely, that's going to be an ethical issue. We can take it as a legal one, right? It's the loyalty that the customer and the shop that should maintain, right? So again, the answer goes with the third one, A and C only. Right. Then comes the 13th. 13th. Consider the following statement regarding tasks carried out on a spreadsheet file in a folder, by a right-handed user. Yeah. So like if it is going to be a right-handed user, that means the way that we use it in normally, right? Place the mouse pointer on the file and single click the right button of the mouse. So what they're asking is, right, which of the above result in opening the spreadsheet file, or to open the spreadsheet file, they say. All right. So how we are going to open the spreadsheet file? First one, they say, place the mouse pointer on the file and single click the right button. Right button will not open you a file. It's just give you the right click menu. Place the mouse pointer on the file and double click the right button. Again, double clicking the right button, that means a right click, gives you the same menu again and again. That means for 2 times. So definitely those two are wrong. So definitely C should be a correct one. Place the mouse pointer on the file and double click the left button of the mouse. Yes. So that is correct. So the answer is going to be C only. Yes, people, is it clear so far? We're moving to the 15th. Oh, where's the 15th? It seems to be on the other side. Ah, yes. Yes, 15th. There you go. Okay, so Excel calculation. Right. So what would be the number displayed if formula has this kind of equation, right? So let's see how this equation going to go, right? So it has equals to the power 3 plus within brackets 5 minus 3 into 6 divided by 4. So the highest priority is given for the brackets. So that means this is going to be behave like this. So equals 2 to the power 3 plus 5 minus 3 happens, that means 2 into 6 divided by 4, right? So that's the way it's going to be. And then now it's kind of a normal one, no brackets, because bracket has been solved. Now it takes the highest priority to the power. So 2 to the power 3 is 8 plus 2 into 6 divided by 4, right? Now the multiplication takes the priority because multiplication and division on the same priority level. Since the multiplication is finding from the left first, we give the priority to the multiplication. So 8 plus 12 divided by 4. So then 12 divided by 4 is going to happen, right? So it is 8 plus 3, which gives you 11, right? So the third one is going to be the answer. Right. Yeah, yes, that's it. It's the same way that we get asked about mass, right? Okay, so after that, 15th and 16th, yeah, they say 16th and 18th. Okay, 16th. So for the 16th, it says they are asking us to consider the Excel sheet. So since I need the Excel sheet, I'm going to clear up the calculation that we did. Okay, so the 16th. In 16th, it says there's a circumference of the circle can be calculated with the formula of 2 pi r, where r is the radius of the circle. Assume that the value of pi is given in the cell C2. Yes. And what formula should be entered into the cell B2? Cell B2 means this particular cell. Cell B2 to calculate the circumference of the circle. So circumference of the circle is given by 2 pi r, right? So if it is given by 2 pi r, that means you have to write the equation like equals to, you should use the star mark, right? Then the pi is taken from here, that means C2 into, and the R comes over here, that means A2. Now, come. Right, so this should be the equation. So you can see the fourth answer is disqualified because it's used power, so it is wrong. And here 2 star is there, but power is used. So due to that, this is wrong as well. Here they use 2 star, but again here they use power, incorrect again. So the only answer that can be taken as an answer is the first one. But there they have used the dollar signs. So it doesn't matter because they have absolute this particular place, right? The value of pi. So $C, $2 will absolute the C2. It's not going to change, right? Okay, so that's how the 16th, for the 16th one, first one is the answer. Right? Okay, then goes to the 18th. Here comes the 18th. Yeah, in the 18th, it is regarding the presentation software, right? So it's the statement A says the animation effects can be applied to multiple objects on a slide. Yeah, animation effects, like that is regarding the animations, right? So animation effects, of course, it can be applied for many different objects, right? It doesn't matter whether it's a square or a picture or a text. You can apply the animations. So that is correct. Right? Oh, no. Right? People, my little one is with me, so getting some noises. Right? So the first one, the statement A is correct. And the second one says the slide transition can be applied to the whole slide only. Yes, slide transition is there to apply to the whole slide. You can't apply the slide transition for objects. The name defines that. Slide transition, it's talking about slide transition. Yes, so that's correct. The slide transition effect appears when slide changes from one to the next during a slideshow, right? So yes, that's why slide transition is there. Oh, right? So the transition, the statement C is also correct, right? Slide transition effects appears when slide changes from one to the next during the slideshow view, of course. Right? So all 3 are correct. Fourth one is going to be the answer. Right? Right. So 18th is done. Then 23rd, you say. Right? Okay, let's move to the 23rd. Where is 23rd? Oh, it's on the other page. Here we go. 23rd. Okay. All right. Consider the following statement related to the database software. They are asking about the database software. A collection of fields related to one object is called a record. Of course, that's the definition given in your book for a record. That is correct. So like when it comes to the tables, so fields means the columns. So columns may get particular, what you call column headers or the field names. Then when you are filling something regarding a particular field names, that gives you or that creates you a particular record. right? So a collection of fields related to one object. One object means the things that you are going to write on the columns, right? So one object is called a record. Yeah. So if you, as an example, if you take admission number over here, right? So if your admission number is 1001, so that this record is about that 1001. So regarding one particular object. And a collection of related tables is called a database, definitely. A collection of related tables is called a database. A foreign key of one table is the primary key of another table. That's correct as well. So to become a foreign key, that particular field should be a primary key of another table. So correct as well. So everything comes as the true statements or the correct statements. All right, 24th. Consider the algorithm in the following flow chart. So the flow chart is given over here. So let's take the flow chart up. And what then they are asking. Yeah, the question says like this. What values will be displayed for x and y respectively if the inputs are x equals 10 and y equals 20? Okay. So if the x equals 10, y equals 20, how it's going to be? X is 10. So x is 10. Y is 20. Right? And input in x and y goes like that. For x we get 10, for y we get 20. Then the question asks whether x is larger than y. X is larger than y. So, I'm sorry, x is less than y. So x is less than 1, right? X is 10, y is 20, right? So of course, x is less than y. Then it goes on the yes part. So in the yes part, it says assign the value of y to z. So there is another variable called z. It's going to give the value of y, 20. So this is happens. Then it says assign the value of x to y. Assign the value of x to y. Then that means 20 is gone. Now 10 is going to be the answer or the value that it takes. So this is done. So this says assign the value of z to x. So the value of z is 20. Assign the value to x, that means 20. So then they are asking display x and y. So x means 20, y means 10. So you are going to receive 20 and 10 as the answer. Okay, that's how the 25th is it. And 24th is done. And the 25th. Consider the following pseudocode with label P to find the product of numbers from 1 to 10. Right? So what they are asking is which of the following expression is correct for the label P? Yeah, so they have used a repeat until structure. So they have something called product. I take it as P. Right, I take P as 1, product 1, and the number I take it as N as 0. So they said repeat until structure that they are using. So in repeat until structure, what we have to remember is when this particular condition is false, then these two are going to repeat. So this should be false. Once until it is producing the value false, this is going to repeat. All right. So P is 1, that means product is 1, number is 0, so repeat. it says number equals number plus 1. For the very first time, before checking the condition, these things are happening. So number equal number plus 1 means 0 becomes 1. Product equals product into number. That means product multiplied by the number. That means 1 multiplied by the 1 comes 1. So assign to the p again. So it is 1 again. Right? Still the value is 1. Now, this particular condition, right? Now, for a moment, let's just think this is going to be its condition. Number larger than 10, right? So number means n according to our entries. So for the moment, it's 1. Right? So number larger than 10 means they're asking the question whether 1 is larger than 10. So it's no, it's false, right? So if it is there, it can be repeated. It can make this repeat. As well as this is going to do the same. Number larger than or equal 10. Still, for the moment, it is false, right? Number is not larger than or not, neither it is equal to 10. That means this one, number less than 10. 1 is something which is less than 10. So number less than 10 is a true, it gives us a true output. When it is giving a true output, the repetition is not going to happen. Because if it is true, then it's going to exit. The second one is not going to be an answer, as well as the fourth one is not going to be an answer. Right? That's clear. Right now, the problem is like to find out what's the answer from 1 and 3rd. So for that, we have to find out what's the pattern of this. So let's assume the condition that they have is number larger than 10. Right? So number larger than 10 for the moment, number is 1. Larger than 10 is not true. So number is going to increase. It becomes 2. Product is going to be 1 into 2. That means 2. And it's not 1. Then again, it checks. Now the number's value is 2. 2 larger than 10. Again, false. So number increased by 1. It will become 3. And the product is going to be product into number. So 2 into 3, it becomes 6. Right? So now we can understand or like see how the pattern happens. Right? When number increases by 1, then it gives us the product. So number becomes 2, 1 into 2 happens. Number becomes 3, 2 into 3 happens. That means 6. The number becomes 4, 4 into 6 is going to happen. 24. So likewise, this is going to happen until 10. Right? Once it becomes 10, then only the multiplication of 10 is going to happen like this. Right? So that means from here, it makes the number 10, the value 10. Then from here, whatever the product that we have will be multiplied by 10. Right? So that gives us the answer, the final answer for the product. Because product is there to calculate the multiplication of the product of first 10 numbers from 1 to 10. Right? Now, when the value of number is 10, we have to stop the iteration. Otherwise, the number will increase into 11. Then the 11 will be multiplied by the product, will jeopardize the answer. So number is 10. So now here, as we assume, if this question is asked, number larger than 10, what's going to be the output or the answer for that? So it's asking, now number becomes 10. 10 larger than 10. 10 is not larger than 10. 10 is equal to 10. So the answer produced as false. If it is produced as false, that means it's going to repeat again because the condition is false. So therefore, first one cannot be taken as an answer as well because we have to stop it when the number is 10. So the correct answer is going to be the third one. Okay, people, are we clear up to this point? Okay, right, moving to the 26th. Question number 26 says, which of the following pseudocode segment is equivalent to the logic of the algorithm given in the flow chart? Okay, now in the flow chart, what they are trying to do is they equals n into 0, then n equals n plus 1, display n whether n is larger than 9. If it is not, that means when n is less than 9, it's going to iterate, right? So we can't say the first one is incorrect just by seeing this n equals 0 in the flowchart and there is n equal 1 in the pseudocode. So what we have to do is we have to figure out what's going on with the particular flowchart, right? So how we are going to figure that out? So for that, we need to hand trace this. So how it's going to happen? It starts, they take n as 0. And so this happens, then they say n equals n plus 1. So this becomes 1. And it says display n. So I'll take this as display. So 1 is displayed. And n larger than 9. They are asking the question whether the n is larger than 9. 1, the value of n is 1. It is not larger than 9. So it goes on the no path. Increase the value of n by 1. That means n becomes 2. Display n. This is 2. Right, so likewise, it's going to go until the n becomes 9. Right? So when the value of n becomes 9, so when n is 1, n was printed. When n is 2, n was printed or displayed. So likewise, when n is 9, 9 will be displayed. That means from values 1 to 9. And then they are asking the question whether 9 is larger than 9. 9 is not larger than 9, right? So it goes up. Again, the answer is no. Comes over here, n is increased by 1. It becomes 10. Display n, then it becomes 10 as well. So now the 10 is larger than 9. Yes, it is correct. So it's stops. So our output, the output has the nature of having the values from 1 to 10. Right? It displays the value from 1 to 10. So now we have to figure out which kind of programs that does the same thing or the same logic which is given in the flowchart. So this starts from n equals 1 and it checks whether while n is like less than or equal to 10, n is less than 10, that means 1. So n is increased by 1, That means n will become 1. I'm sorry, n will become 2 because n start as 1. So once increase, n will become 2. Then it asks to print n. So 2 will be printed first. But in our flow chart, 1 must be printed as first. So due to that particular statement, we take this as an incorrect one. For the second, it says for n equals 0 to 10. So that means again n deviates from 0 to 10. So then it says display 10, display n, right? So when n is 0, the initial value of n is 0, it's going to display the n. So that means 0 is going to be there at the output, the very first output. But our very first output gives 1. Right? So because of that, second one is wrong. So the third one. Third one starts n as 0. Right? So n start as 0. So the question is asked whether n is less than or equals 10. So it is less than 10 because n is 0. Right? And it says display n. That means you are going to show a 0 in your output list. But we are not going to show a 0. We are showing 1. So because of that, this is wrong. So the correct answer is going to be the fourth. In the fourth, n start as 1. Right? And it increases up to 10. So while n is 1, it says display n. So the n is displayed, that means 1 will be displayed. Then after 1 by 1, n will be increased. So per increment, display will happen. So from 1, then it displays 2, then it displays 3, 4, likewise, up to 10 as the last one. So we got the last one as 10. So the fourth one is going to be the answer. Right. So 27th. Where is 27th? Now it is at the bottom. Let me see. Yeah. It's 30 minutes. You don't do that. I'm not going to give this to you. Okay, 27th. So the 27th, it says x equals 0. Right? So when x is 0, it says do display star x equals x plus 2 while x less than 5. Right? So it starts like x equals 0. So this happens, then do, it says display a star. So let's take this as display. So it shows you a star. And it asks you to increase x by 2. So x becomes 2. And then it checks whether x is less than 5. So that is very class. So x is less than 5. Yes, 2 is less than 5. That means this is true. Yes. Then it does display star again. It shows the next time. Increase x by 2. Sorry for my kiddos sounds people. So 2 becomes 4. Right? And it checks whether the x is less than 5. Yes. So the x is less than 5. 4 is less than 5. So it goes and repeat this again. Display a star. So it displays a star. X is increased by 2. 4 is becoming a 6. And now the while condition, x less than 5. The value of x is 6 now. So it is not less than 5, so it is wrong. So the program ends. So the output must display 3 stars, but 3 stars are not there, right? So because of that, you have given all marks, right? So for 27th, if any answer is the correct one. Now, when you are not getting an answer in your question paper, please mark some answer, right? Then only you will be going to get marks for that. If you are not marked it, then you will lose the mark, right? So it's better you mark some particular answer in your answer script, right? So 28. 28, the question is, consider the following pseudocode. So it gives, if average larger than 70, then if sport color equals true, then all around the award equals true. They're asking what's going to be the equivalent logic for the above pseudocode. Yeah. So the average is larger than 70. This should be correct to come to the next if. Then when it is correct, then it gives you this assignment. That means both the conditions should be satisfied to have true assigned to the all-rounder award. That means we have to go with AND clause, because AND clause is the one which considers both the conditions are true or not. So the correct answer is going to be the first one. O will give you, or like O will assign true to the all-rounder award for any of the correct conditions, right? It doesn't matter whether both things are going to be correct or not. Just one being correct is enough, right? And not the third and not the fourth, because they are individually thinking about the conditions. Right. Then comes 33rd. No, the 30th. I'm sorry, the 30th. Let's see what's the 30th is. 30th. Which of the following is proposed to deployment approach for the above information system? Yeah, now at the end of your scenario, at the very end, it says something like this: the librarian suggests that both manual system and the new system to operate till they make sure the new system works without any problem. So if the implementation goes like this means the parallel implementation. Parallel implementation is the implementation which takes old system and the new system runs together until the new system is satisfied with the users, right? So for 30th, it's the first one, the parallel. 33rd. Let me check the 33rd. Oh, it's on this side. 33rd. Is it something HTML? Okay, it's regarding the emails. Okay. So when it comes to the emails, it says consider the following segment of an email sent to Ajit and 3 others. So the Ajit is the main recipient. Rizvi is taken as the CCs, that means the carbon copies, and the BCC is taken to the frag. So Ajit will be able to see the CC people, and CC people will be able to see the Ajit as well. And the BCC people will be able to see both the 2 and the CC people. But rest of the things cannot. CC cannot see the BCCs. 2 people will not be able to see the BCC recipients. So they are asking what's true. Who are the recipients that Ajit will see as having received this email? Yeah, they're asking which email addresses that Ajit can view. So Ajit is the main recipient. So he can view these two only, not the Frank. Right? So not only Ajit DOLK, only Ajit, Rizvi and Kumar. Yes, that's the correct one. Ajit DOLK, Rizvi, Kumar and Frank are them. Only Ajit and Frank, not Frank. Frank, Ajit cannot see it's Frank being BCC. Right? Blind carbon copy is there to send a particular email in a secret way to a receiver. So once the Frank will receive it, Frank can see every one of these, but none of them can see the Frank. 34th. Which of the following in HTML can be used to provide substitute information for an image if a user cannot read the image due to slow internet connection, or let's say the image is not going to load. If it is slow, image is not going to load. So that means you can see the alternative text, which goes under the ALT tag, not the tag, ALT attribute, right? So the third one. SRC is defining the source. Href, we don't use it in the image tag. IMG is the tag name, right? So the ALT, the alternative text, going to see, right? Going to have the alternative trace. And 35th, what is the correct HTML code segment for creating the hyperlink Ministry of Education for this particular web address? So anchor tag must be used, and href attribute should be there. So they have used anchor tag and they don't have href. They have written the web URL at the outside of the anchor tag, so it is wrong. Anchor tag is used, href is used, correct. The correct address is used, the web address, and Ministry of Education. This is the one that you are going to see on your web page, and then anchor tag is closed. So second one is going to be the answer. In the third one, they use something called name with the anchor tag. Name can be used, but it does not define, or like it does not give the link for this particular web page. Because of that, this is wrong. And URL, we can't use something called URL with the anchor tag. So it does not define what the web address is, only the href. So the fourth one is wrong as well. Second one is the answer. Then 38. Consider the following statements. Uninterrupted power supply, software firewalls, use of username and password to log into the computer. So what they are asking is, which of the above are example for logical security? Logical security means you can't use any physical components, right? Like UPS for the power supply and surge protectors for the lightning kind of situations. Right? It's only logical things like username, passwords, access privileges, those kind of things. So uninterrupted power supply, it's a physical one. So A should not be in your answer. Software firewall, it's a software, so application. There are hardware firewall as well, but here they are talking about software, so it is an application. That means it is logical. Use of username and password log into your computer, it is logical as well. So B and C only. 39th, which of the following are examples of safe use of internet? Hiding personal information such as telephone number and addresses on social media. Yes, that's a safe way of using the social media. Those are our private things or private details, telephone number and addresses. So we should share it only with the trusted people, not with everyone. Clicking on links in emails that comes from unknown person, we should not, because it can be a spam, it can be some particular malware, right? So we should not click on the links we see from unknown people. Communication with strangers on social media. No, you should not do that. Social media is just a virtual community. So in the virtual community, we should use that to in touch with the people who we know on the real world, right? At least we should have a good connection with them. not through the social media, before the social media. So we can connect with them through the social media. So A only is going to be your answer. 40th, the very last question. So it says, consider the following statement. Careless disposal of electronic waste into the environment, handing over unusable compact fluorescent light bulbs and other electronic devices to the recycling center, sell or donate working electronic devices to the other without discarding them. Which of the above are examples to safe e-waste disposal? So like when it comes to the e-waste disposal, we have 3R system, right? So reduce, reuse, and recycle, right? So careless disposal of electronic waste into the environment, no, it is not a recommended way. Handing over unusable compact fluorescent light bulbs and other electronic devices to the recycling center, yeah, that goes with the recycle, correct. Sell or donate working electronic devices to other without discarding them. So that implicates the reduce and reuse as well. Like selling or donation will implies the reduce. When it is being purchased by someone else, that means reuse, right? So this is correct. So the correct answer is going to be B and C. Okay, so people, that's the way we are going to discuss the paper. So we successfully discussed the first paper of the 2017. So by next week, I'm going to discuss the second paper. So please be prepared. Do all the questions, people, right? So I can discuss all the questions, right? So you time it and first do 5 questions, then you can do the rest of the things. Without considering the time. So consider the time will be a good always, but you don't need to when you are doing extra questions, right? Okay, people, so thank you very much. I'm going to see you on next week for the very same time to discuss the second paper of the 270. Please be prepared, people. The people who have not done it, get ready with the answer script. Right, thank you very much, everyone. I'll see you on next week. Have a nice day.